This is Math 261. This is section 13.6 on the directional derivative and gradients. And this is part 2, page 3. So we're in this example to find the directional derivative of this function at this point in the direction of this angle, negative pi over 6. So in order to plug into this formula for the directional derivative, we need to calculate the partial derivatives. So let's go ahead and do that. Now, the partial derivative with respect to x means y is going to be treated as a constant. So I didn't write derivative here because I want to, this is not necessary and it may not be that much work saved, but since y is a constant, we can rewrite the original function this way, like as if y were a number. We could do that. We could also use the quotient rule, which is perfectly fine. For the next one, we're going to have to use the quotient rule. But for the partial derivative with respect to x, where we treat y as a constant, we can do it this way. So we'll bring down the negative 1, so we get negative y times 2x plus y to the negative 2 power times the derivative with respect to x of 2x plus y, which would be 2. So times 2. So this will be equal to negative 2y over 2x plus y squared. Now for the other partial derivative with respect to y of f of xy, we'll use the quotient rule. So we'll have the denominator 2x plus y times the derivative of the numerator with respect to y, which is 1. The numerator is y. Then minus, that's the derivative times the derivative of, the denominator times the derivative of the numerator minus the numerator y times the derivative of the denominator with respect to y. The denominator is 2x plus y. So the derivative of that with respect to y is 1. And then this is all over the denominator squared. 2x plus y squared. Like so. So the numerator will get 2x plus y minus y, so we'll get 2x over the quantity 2x plus y squared. Then in order to evaluate the directional derivative, we're also going to have to know the cosine and the sine of negative pi over 6. So here's our 30, 60, 90 right triangle, 1, 2, square root of 3. But in this case, it's negative pi over 6. So if we put the angle into standard position like that, this would be this triangle, but we could consider this as negative 1. This would be radical 3, and this would be 2. So the cosine of negative pi over 6 would be adjacent, which is radical 3, over hypotenuse 2. And the sine of negative pi over 6 would be opposite, which is negative 1 over hypotenuse. So negative 1/2. And now we have what we need to write down the directional derivative. So this is equal to the partial with respect to x times the cosine of the angle, which is radical 3 over 2. Plus the partial derivative with respect to y times the sine of the angle, which is negative 1/2. And then we can simplify this a bit because the two 2's cancel. So this is negative y square root of 3 over the quantity 2x plus y squared. And then that's minus x, because these two 2's cancel, over 2x plus y squared. And then because the denominator is the same, we can get this expression for the directional derivative in the direction of this particular vector, u. And also now we're supposed to plug in specific values for x and y, which are 3 and 0 for x and y. So d u of f of 3 comma 0 would be, so we'll plug in here, y is 0, so that becomes 0 up top, minus 3 over 2 times 3 plus 0 squared, so that'll be negative 3 over 6 squared, which would be negative 3/36.